I was talking to you guys as you were working, and I saw a bunch of you using the strategy with all x's first, right, to anchor yourself in the algebra and help support you as you navigated this more complicated equation. Christopher in my last class was just really good doing all of this in his head and getting to a place where he had cosine inverse of square root of 3 over 2 on his paper. He wrote nothing else. It was impressive. From here then, I used my circle, and it looks like everybody was coming up with correct answers of pi over 6 plus 2 pi k and 11 pi over 6 plus 2 pi k. Why the 2 pi k again? I have an infinite amount of solutions. My interval includes infinities, and this captures more and more rotations around the circle. In fact, like an infinite number of rotations. Okay, Ralph, I think is one of the, like this table over here was getting a head start on some of these extra examples, which I like, to up the bar a little bit. So let's catch up with where they're at and try one of these that will push our thinking just a little bit more. First one. We see an equation here, 4 sine squared of x plus 1 equals 4. If you are someone who is appreciative of that algebraic simplification first, the only additional piece here is that I would not be able to write this as 4x plus 1 equals 4. Anybody anticipate what's missing? A square. This is 4x squared plus 1 equals 4. I also realize some of you don't need to be writing it in x's anymore, and if that's you, just kind of mirror my steps over here if you want to. But if you want to work in x's, I'd move the 1 first, right? I'd have 4x squared equal to 3. I'd divide by 4, and x squared would equal 3/4. If you're working on this part of it, that means I've gotten to a place where sine squared equals 3/4, right? See the alignment here. How would I solve for x in this algebraic scenario? Square root. I don't know how many times I say this, but be careful, because when you square root, you actually get 2 sets of solutions. Positive solutions and negative solutions. Plus or minus. Always attaches when we physically square root something. Another thing I noticed on some of your algebra assignments is that we're having trouble when we have a radical over a fraction.
Oh, I see.
That means that you put a radical on your numerator and a radical on your denominator. And the denominator is nice, right? Because I know the square root of 4 is just 2. It turns out I have plus or minus the square root of 3 over 2. So over here in my trig setting, that means sine of x is going to equal plus or minus the square root of 3 over 2. I'm going to let you guys try and find these answers on your circle too, but how many answers do you anticipate having?
4.
4. 2 positive answers, just like we've seen on all of our examples so far, and the 2 negative examples. Try and find those values real quick before we try one with tangent.
Okay. This one is 1? 7 pi over 6?